Hey everyone, and welcome to this explainer. Today, we're exploring the absolute, downright critical toolkit for validating product ideas. We're going to look at how you can test your concepts without, throwing away precious time, money, or software architecture. Because whether you're an entrepreneur, an architect, or a product manager, understanding these validation tools is exactly what separates the really successful launches from the super expensive failures. All right, let's kick things off with a pretty sobering reality. 34%. That is the percentage of startups that fail simply due to a lack of product-market fit. And a massive contributor to that failure rate, it's that teams just rush blindly into full-scale development. They basically build first and ask questions later, rather than actually validating their assumptions early on. Okay, let's dive into this, because the core problem usually starts before a single line of production code is even written. Confusing different validation concepts is literally the fastest way to miss your mark. You know the story. One founder jumps into building a minimum viable product before confirming if the tech is even feasible. Or another spends months on this beautiful interactive design when real users should already be testing the actual functioning product. So you gotta ask yourself, are you picking the wrong approach for your specific risk? To figure that out, here's our roadmap for today. We'll hit 1, the validation dilemma, 2, defining the core toolkit, 3, real-world validation examples, 4, the PoC problem, 5, a framework for PoCs, and finish up with 6, choosing the right path. We're going to start with high-level business strategy and drill all the way down into deep academic software architecture. So, Section 1, the validation dilemma, building the wrong thing. Look, the stakes of building the wrong thing at the wrong time are just massive. You could easily burn through months of runway building a product that nobody actually wants, or scaling a system that fundamentally cannot handle the technical load. Moving right along to Section 2, defining the core toolkit, terms you must know. To avoid a massive failure, we absolutely must clearly define 4 terms that get conflated in, almost every pitch deck and planning meeting. Using them interchangeably is a recipe for disaster. First step is the proof of concept, or PoC. A PoC is a very small, narrowly scoped technical test. It really answers one core question: can we actually build this? The absolute crucial point here is that PoCs prove technical feasibility. They aren't for the public at all. They are targeted exclusively at internal teams, engineers, and stakeholders to prove that an algorithm works or that 2 really complex systems can actually integrate. Next, we have the prototype. A prototype is an interactive model answering the question, should it work this way? Prototypes are all about proving usability and user experience. We're talking clickable screens, wireframes. They focus entirely on design, navigation, and user flow, rather than the heavy backend code. You run this when you want to know if a user will actually find your interface intuitive. Then there's the minimum viable product, the MVP. This is the absolute simplest functional version of your product, and it answers the massive question, does the market want this? Clarifying this is so important. MVPs test genuine market demand by putting a functional, stripped-down product right into the hands of real external users. Real data, real usage, real feedback. And finally, the pilot. A pilot is a live rollout with a small controlled group of users answering the question, does it scale effectively? Pilots are often used in big government or enterprise settings. You take a fully developed solution and offer it to a limited population, just to catch those tricky operational or scaling issues before you pull the trigger on a massive public launch. And comparing the purpose, timeframe, and cost for a PoC, a prototype, and an MVP brilliantly illustrates the progressive investment required here. Think about it. A PoC is cheap and fast, maybe a few days and a couple $1,000s to test a technical risk. A prototype asks for a bit more time and money, right? To test design risk. But an MVP, which requires real, actual software development across the front and back end, that demands weeks or even months and significantly more capital. You absolutely do not want to spend MVP money to answer a basic PoC question. Okay, Section 3, real-world validation examples. Validation in action. It's always super helpful to anchor these abstract tech terms to familiar stories, just so you can see exactly how the world's most successful companies validated their big ideas. Consider Amazon Go. Before launching to the public, Amazon built a massive 15,000 square foot mock supermarket inside a rented warehouse. That was a pure proof of concept to see if their computer vision could actually track shoppers accurately. In contrast, look at Dropbox. Drew Houston validated pure market demand with a simple 3-minute demo video that acted as an MVP. It literally drove beta signups from 5,000 to 75,000 overnight. And Airbnb? Their MVP was just listing their own single apartment on a basic website to see if strangers would actually pay to sleep in someone's home. Different risks completely dictate different validation tools. But here's where things get a bit complicated. Section 4. The PoC problem. Undocumented experiments. In software architecture, there's this major pitfall in product development, which is treating PoCs way too informally and letting them drive massive, completely undocumented choices that end up haunting your architecture for years. Recent academic research highlights what's called the undocumented architectural experiment anti-pattern. Basically, the problem is that teams build a PoC, they figure out a solution, and then they throw the whole thing away. Or actually worse, they deploy that messy, hacky PoC code straight into production. What we need to do instead is separate the PoC into two things. The actual code, that's a disposable implementation artifact. You literally throw it away. But the metrics, the scenarios, the lessons learned, that is a durable experimental artifact. That knowledge absolutely must be preserved to justify your future architectural decisions. Which brings us to Section 5, a framework for PoCs, first-class instruments. To solve this anti-pattern, academic literature proposes elevating the proof of concept from an informal, messy experiment to a first-class architectural decision instrument. We just need to apply a little bit of rigorous structure. When we connect the dots, we can see exactly what a structured PoC does. Notice how characteristics like trying to determine feasibility and running quicker experimentation map directly onto the formal definition of assessing feasibility and running a short-term experiment. A PoC isn't just messing around with code for a weekend. It's a highly targeted strategy to solve learning needs, evaluate risks, and ultimately drive formal decision-making. To pull this off, the researchers propose a really lightweight, three-phase framework. Step 1 is planning. This is where you define your exact hypotheses, identify your stakeholders, and establish strict success metrics. Step 2 is execution. You run controlled scenarios in a constrained environment. And remember, this isn't to build a product, it's just to gather data. Step 3 is decision-making. You analyze those metrics to adopt, reject, or revise an architectural approach. And crucially, this yields a recorded architecture decision record, or ADR. When you map this structured execution process out, it highlights the exact intersections between the business, the collaborative, and the technical roles. You define the prerequisites and metrics up front. Then, down in the technical lane, you execute the PoC for each scenario, and you monitor those metrics closely. Those metrics then feed right back up into the collaborative decision-making phase. If the metrics are sufficient, boom, you make your formal architectural decision. It creates this beautiful, closed, logical loop of evidence-based engineering. Finally, we arrive at Section 6, choosing the right path. Which tool do you need? We've talked about high-level business strategy, and we've talked about deep architectural documentation. Now, let's combine all of that into an actionable takeaway for your very next launch. So, here is your ultimate decision framework. If you were facing high technical risk, like, say, unproven AI models or some crazy complex database integration, you absolutely must start with a POC. Keep the code disposable, but keep the data on record. If your product relies heavily on user experience, start with a prototype to nail that navigation. And if the tech is pretty standard, but you just need to test actual market demand, go straight to an MVP. Always match your validation tool to your biggest unknown. I want to leave you with this final, somewhat provocative thought to consider for your own product lifecycle practices. When you run an experiment, are your architectural decisions formally on the record, or are they just ghosts haunting your codebase? Validate your assumptions early, record your evidence, and build with absolute confidence. Thanks so much for joining me for this explainer.